Escalation model is actually a gradient boosted classifier represented in the diagram here. And what that means is that it's a series of decision trees or decision stumps. So this is a decision tree. All of them individually are very bad at their job. But when you add them up sequentially, they become greater than the sum of their parts. And how that works is you train this first model, and it will detect some very simple pattern in the data, and it will be able to predict maybe a couple of the cases or a couple of the samples of data. And then you take the prediction residuals, which is just a fancy way of saying the ones that got wrong, and you weight those errors so that the next model is able to correct, if you like, the errors of the previous decision tree. And there's a few shown here, but this can be hundreds or thousands of decision trees run in a sequence. And at the end of it, you have what actually is a very powerful and very, very good model. One of the kind of features of gradient boosted classifiers is that they have a lot of model capacity, which means they can learn like very complex and convoluted like patterns in data, very complex decision boundaries. And that's perfect for escalation prediction, right? There's so many nuances to data that can, or to a case that can result in escalation. So having a model like this that can really adapt to all of those nuances is great. It does come with the caveat that it needs a lot of data to train on, to not fit and focus too much on some simplistic patterns it's seeing and not generalize to the whole environment. So the data that this is trained on is historical escalation data. So we look at customers' historical data, cases that have escalated, cases that haven't escalated. We actually use time series analysis to break up those cases into chunks of time. Obviously, in the lifespan of a case, there's so much that's happening. So what happens on day 1 at a case might be nothing to do with why it escalated on day 45. So we want to look at discrete time intervals throughout the case. So we're able to learn what a case looks like before it escalates, as well as right up to the boundary of escalation. We also include our customer feedback here as well if we have customer feedback. So obviously, when we're onboarding new customers, we're just looking at historical data. But as our customers are using the escalation model and giving their feedback on it, we also incorporate those labels into the training data in the same way. A new model will incorporate customer feedback as well. And then, so at inference, we're taking a case at that kind of snapshot in time, and we're looking across like 70 features that this model has learned the weights for. And we're applying those weights at inference to see if we think a case is likely to escalate in the next time period.